Welcome back, guys. Okay, this is just a continuation of the polar form of complex number from the previous video. So now here we'll do some application of how we can convert the rectangular form into polar form. So I'll start with part 1 there. We begin with part 1. So if you see, part 1 is we've been given 3 plus 3i. Yes, so we want to convert this one into what? Polar form. So I'll say I'll let my z be equal to what? 3 plus what? 3i. Then I'll say let me find what? R, and we know that R is just equal to the magnitude of what? Of z, which is just the what? The root, and then we square 3 and 3. So what are we going to have there? So my R will just be equal to there we'll have something like 9 plus what? Plus 9, and I'll have my R to just equal to the root of what? 18 there. And we know that 18 can be written also in the form. We know that when I multiply 2 by what? By 9, I'll get what? 18. And we know that I can write this in this way, in that way. And we know the square root of 9 is what? Is 3. Somehow something which is going to look 3 and the root of what? And the root of 2. But if you want, you can just leave it in this way. It's just fine. So we have found our R to be just what? 3 and the root of what? Of 2. So now we find our what? We find our argument. So our argument of z is just equal to the what? To the tan inverse of what? Of y over what? Over x. What is our y? Our y is just equal to 3, and our x is also equal to what? To 3. So there my argument of z, it will just be equal to the tan inverse of what? 3 divided by 3. I'll just have what? 1. So we are going to have the tan inverse of what? Of 1. What is the tan inverse of 1? We'll go back to our table which we did. So as you can see on this our table, we'll come out here. It's our tan. So let's go where there is 1. Here is where 1 is. 1 is right where it's here, and where here it's 1. And what is our angle? Our angle, it will just be what? 45. So the tan inverse of 1 is just what? 45 degrees. So now we have 45 what? Degrees there. So now the second step is just to let's try to prove if this angle we have found is the actual angle you're supposed to use. So let's try to check that on what we call the what? The Cartesian plane. So I'll just draw it quickly there. Then I'll say my y, it's here, and my x is there. So my x is positive 3. It can be somewhere there. And my y is also positive 3. It can be somewhere there. So they are meeting in the what? In the first quadrant. So they are meeting in the first quadrant. Now, since they are meeting in the first quadrant, that implies that the angle which you have found here is the true angle to what? To use. But if x, let me say for instance, maybe x, so let me say for instance, maybe x, it was equal to negative 3. So it would have appeared in this way, and they would have met in the what? In the second quadrant. And what happens in the second quadrant is just 180 what? Minus, which means this angle which I found it here, I would have said 180 minus what? 45. But that's not what the case is. There my x is positive and my 3 is positive, and it's lying in the what? In the first quadrant. So which means the angle which I found here is the actual angle to what? To use. So now I'll say my z, it will just be equal to, what is my r? Is 3, the root of what? Of 2. Then I'll say cos, what is my angle? Is just what? 45 degrees plus I sine what? let me write it properly. So I'll just say cos what? 45 degrees there, plus I what? Sine what? 45. Sine 45. Or you can write it in this way: z is just equal to what? My r is just what? 3 the root of 2. So that is my magnitude, and there must be less than what? The argument. What is my argument? It's just what? 45 degrees. It also what? Correct. So let's move on to part 2. So on part 2, we have been given 1 plus I, the root of what? Of 3. So just let my z be equal to what? 1 plus I, the root of what? Of 3. Then I'll say, let me find my what? My r, which is just the what? The magnitude or the modulus of what? Of z. And we know how to find this thing. I'll just square 1 there, plus the root of what? Of 3. Also square it there. Then I'll just say, let me say that I'm going to have something like 1 plus there 2, and this square root to go. I'll remain with what? With 3. And I'm just going to have the what? The root of 4. And you know the root of 4 is just equal to what? To 2. So our r is just to 2. So now I'll just say, since now I found my r, let me find my what? My argument. So we all know that our argument of z is just equal to the what? To the tan inverse. It's the argument of the what? Or the amplitude. The tan inverse of y over what? Over x. So this is my y. This is my what? My x. So there I'll just say, I'll have something like the tan inverse. My y is just what? The root of 3, and my x is just what? 1. So I'm going to have the tan inverse of what? Of the root of what? Of 3. So we go back to the table. What is the tan inverse of the root of the square root of 3? So let's try to check on our. So now, if you go back, the tan inverse of the root of the square root of 3, it's here, and our angle is just what? 60. So it's just what? 60 degrees. So we have found our angle to be what? 60 degrees. So now let's prove this angle if it's the correct angle you're supposed to use. So quickly, I'll just draw the Cartesian plane there. So my x is positive 1. I know it can be found there in the positive axis, and my y is just the root of 3, and I know it also can be found where? Up there in the positive y-axis, and they're also meeting in the what? In the first quadrant. So what did I say? If they're meeting in the first quadrant, which means that this angle, this argument we have found is the what? Is the one you're supposed to use. Is the correct angle we are supposed to what? To use. So now I'll just say, okay, my z to now just be equal to what is my modulus. My modulus we found it to be what? 2. Then I'll say cos what? Cos 60 degrees plus I sine what? Sine 60 degrees. And that is your answer. Or you can write it in this way. I wanted to write it in this way: z to be equal to 2, and let it be less than the what? The argument, which is just what? 60 degrees. Also what? Also correct. Just like that. And what if you are dealing with radians? You want to convert it into radians. Simple. You say, no, me. I don't want to use the angle. I want to use it in radians. Just say, let my rad be equal to. I'll just say pi over what? 180. I'll multiply it with what? With 60. That's all. Then you have what? Convert it into what? Into radians. Just like that. Let's move on to part 3. So part 3, we have been given negative 2 the root of 3 minus 2 what? 2i. I'll just say let my z be equal to negative 2 the root of what? Of 3 minus 2 what? 2i. Then I'll say no. Let me find my what? My r. My r is just equal to the magnitude of what? Of z, and we know how to do that. It's just by squaring negative 2 the root of what? Of 3 there. I square it plus negative 2. I also do it what? Square it. What am I going to have there? I'm going to have something which is going to look like I'm going to have something like 4 there, then I'm going to have 2 and this square root it will go, have a 3 there, then plus 4 there. And I know I'm going to have something which is going to look like here is going to be what? 12 what now plus what? Plus 4. And there when I add, I'll just have something like the square root of what? 16. And the square root of 16 is just what? 4. So we have found our r is just equal to the what? Is just equal to what? To 4. So now let us find the argument. So we know that our argument of z is just equal to the what? To the tan inverse of y over what? Over x. We know our y and our what? Our x. This is our y. This is our what? Our x. So I'm going to have something which is going to look like the tan inverse. My y is just what? Negative 2 over there. I'm having negative 2 and the root of what? Of 3. So negative 2 and this negative 2 will go. I'll just remain with what? With the tan inverse of 1 over what? The root of what? Of 3. We go back to the table and try to check what is the tan inverse of 1 over the root of 3. So now if you check the tan inverse of 1 over the root of 3 here, our angle is just what? 30 degrees. So we go back. So our angle is just what? 30 degrees. So now let's prove if this is the actual angle we are supposed to what? To use. So I'll draw a diagram first. Then I'll say my y or my x is given what? Negative 2 the root of the I say this thing it will appear in the what? In the negative x-axis. And then I see even my y is also what? Negative 2i, and I see no, it will also appear in the negative what? Y-axis. And they are falling in the what? In the third quadrant. And what happens in the third quadrant? Just 180 plus, which means that my true angle it will just be equal to 180 plus what? Plus 30. You see? And I'm going to have 210 degrees. So that is my true angle which I'm supposed to do what? To use. So now I'll just say let my z be equal to what is my modulus? It was just 4. Then I'll say cos 210 degrees z plus I plus I sine 210 degrees, just like that. Or I'll write it in this way: 4 less than what? 210 degrees. Also what? Also correct. Let's move on to part 4. So now we have been given on part 4 we've been given the root of 2 minus I, the root of what? The root of 2. I'll say no, let my z be equal to what? The root of 2 minus I, the root of what? Of 2. Then I'll say let me find my r, and we know that our r is just equal to the magnitude of z, and we know how to find this thing. It's just by what? Squaring the root of 2 and doing the same thing to the other one. I square it, and what am I going to have? This 2 and this square root will go, this 2 and this square root will go. I'll just remain with 2 plus what? Plus 2 to just give us the root of what? Of 4, and we know that our r will just be equal to what? To 2. And now we find our what? Our argument. We know that our argument is just our argument of z is just equal to the tan inverse. So it's just equal to the tan inverse of y over what? X. My y there is just equal to the negative root of 2, and my x is just equal to the root of what? Of 2. From there, so now I'll just say my argument will just be equal to the tan inverse my y. So I'll say my y it will just be now what? The root of 2 over the root of 2, and this will just give me what? The tan inverse of just what? Of 1. And we know that the tan inverse of 1 is what? The tan inverse of the tan inverse of 1 is what? 45 degrees. Let us prove if it's the actual angle you're supposed to use. So I'll quickly draw my diagram there. We know this is my y, this is my x. My x is positive, I know it will appear from that side, and my y is negative. The root of 2, I know it will appear from that side. So they are meeting in the what? In the fourth quadrant. And what happens in the fourth quadrant? Just 360 minus. Meaning I'm going to say what angle did we find? It was what? 45, right? Yes. So I'll just say 360 minus 45 degrees. And I'm going to have what? 315 degrees. So that is my true angle which I'm supposed to what? To use. So I'll just say my z to just equal to what is my modulus or my magnitude. It's 2. Then I'll say cos what? 315 degrees plus I sin what? 315 degrees. Or I'll just write it in this way, 2 less than the argument, which is what? 315 what? Degrees. And you are done. We move on to part 5. Part 5. So part 5, we have been given the negative root of 3 plus what? 4i. I'll say, let my z be equal to the negative root of what? Of 3 plus what? 4i. Then I'll say, let me find my what? My r, and we know our r is just equal to the magnitude or the modulus of z, and we know how to find this thing. I'll just say the negative root of 3 square it plus 4, I'll square it. Then I'm going to have something like this 2 and this square root to go. I'll remain with what? With 3, and there I'm going to have what? 16. From there, I'll just say the root of what? 19. I don't like my 9. The root of what? 19. What's the square root of 19? I don't know. I think we don't have. So now since we have found our r, and we say, let me find my argument. Argument of c is just equal to the what? To the tan inverse of y over what? Over x. Over x. What is my y? My y is just equal to 4, and my x is just equal to the negative root of what? Of 3. The negative root of what? Of 3. Then I'll say the tan inverse of 4, then I'll divide by the negative root of what? Of 3. So what's the tan inverse of 4 over the negative root of 3? On our table we don't have such kind of angle, so it will be hard for us to find this thing, but easy. You guys don't use a calculator, but if you are using a calculator, this is simple. You just do the tan inverse of this thing. It will just be straight and forward. It will give you maybe something like 66 point something, yeah, something like that. If you do the tan inverse of 4 over the negative root of 3, you're going to have something like negative 66.58, something like that. But you guys don't use a calculator, so you can just say, since this thing is just simple, I'll just do. So you just say my z, it will just be equal to, what is my magnitude? It's just the root of what? 19 there. Then I'll say cos. What is my angle? My angle, it will just be the tan inverse of what? 4 over the negative root of what? Of 3. You close that one plus I. Let me write it properly. So you just say my z, it will just be equal to the magnitude, which is just the root of 19, cos, in bracket you say the tan inverse of the what? Of 4 over the negative root of 3 plus I sine the tan inverse of 4 over the square root, the negative root of what? Of 3. Then you're done. We move to part 6. So on part 6, we only have negative 11. Then you say, I've been only been given a negative 11. I'm supposed to have the what? The real part and the imaginary part. I don't have the imaginary part. What do? I'll say, let my z be equal to negative 11 plus 0i. You see, I've included 0i because we have nothing there, so I've included the what, the imaginary part. So then I'll say let me find my r. We know our r is just equal to the magnitude of z, and know how to find this thing. I'll just do what, square my 11 and also what, my 0 there. My 0 there. Then I'll say the square root of what, of 11. It will just give me what, 121, and the square root of 121 is just what, 11. So my r is just equal to what, 11. My r is just equal to 11. And now you just say let me also find my what, my argument of what, of z, which is just equal to the tan inverse of y over what, x. My y there is just equal to 0. My x there is just equal to what, negative 11. Then you say this will just be equal to the tan inverse. What is my y? It's 0. Divide that by what, negative 11, and I'm going to have the tan inverse of 0. What is the tan inverse of 0? It's just equal to what, to 0. So let us now prove, are we supposed to use 0, or maybe there is another angle you're supposed to use? So let's try to what, to check for that. So I'll just draw a diagram there quickly. I've been given this is my y, this is my x. My y is 0, so it will just start there at the beginning. Then I'll say what is my x? My x is negative 11. I know it's falling in the what, in the negative x-axis. So as you can see, this is lying in the what, in the straight line. It's lying in the straight line. And we know that a straight line adds up to what? A straight line adds up to what? To 180 degrees. Because here it's 0 degrees, here's what? It's 90, here's 180, here's 270, and 360 there. So this is falling where? In 180 degrees. So our true angle is just equal to what? 180 degrees. So now you just say, okay, I'll just write my z to just be equal to my magnitude is just 11. Then I'm having the cos of what? 180 plus I sine what? 180. If you want, you can't write 180. We know that 180 is just equal to what? To pi in what? In radians. So you can put pi here if you want. You can change this and say pi plus I sine pi here. Or you can say my z just equal to 11 less than the argument to just 180 degrees. It's also what? Correct. We move on to part 7. So the last part I've been given, part 7 is saying that you only have the negative I of the root of 7. Then I'll say, no. I'll let my z be equal to what? Negative I, the root of 7 plus what? 0. You see? Plus what? Plus 0. Then you say, no. Let me find my what? My r. So my r, we know, is just equal to the magnitude of z, and we know how to find those things. I'll just say the negative root of what? 7 squared plus 0 what? Squared. So now from there, I'm going to have just the root of what is this 2 and this square root. It will just what? It will go, and I'll just remember what? Just the root of what? Of 7. So my r is just equal to the root of what? Of 7. And then you say, let me also find my what? My argument of what? Of z, which is just equal to the what? To the tan inverse of what? Y over x. Then you go back. What is my y? What is my x? So relating that in order, you say my z is just equal to 0 minus I, the root of what? 7. Then now you can predict my y is just equal to what? To the negative root of what? Of 7, and my x is equal to what? To 0. So now you can see I'm having the tan inverse of what? What is my y? Just the what? The root of 7, and my x is just what? 0 there. Then here I'm going to have it's going to give me something which is what? Undefined. And when you have something which is undefined, just know that your answer is just equal to what? To infinity. You see, just know that your answer is equal to what? To infinity here. So we are saying that so I was saying that it will give you something which is what? Undefined. So when it gives you something which is undefined, just say I'll just say my tan inverse, it will just be equal to what? Infinity. So this, it will goes to what? To infinity. And when it goes to infinity, you're going to say, what is the tan inverse of infinity? So when we go back and check on the table, we say that the tan inverse of infinity is equal to what? 90 degrees. It's just equal to 90 degrees. Let's check on the table. So the tan inverse of infinity is just equal to what? 90 degrees. So now we are going to say, am I supposed to use 90 degrees? Let's test it on the what? On the Cartesian what? On the Cartesian plane, and see if it's the actual angle you're supposed to use. So I'll draw it there quickly. Then I'll say my y, we said, is just equal to the negative root of 7, and my x is equal to 0. So my x there, my y, the negative root of 17, I know it will appear somewhere there. So it's falling in this direction where it's 270 degrees, where there is an angle of 270 degrees. So meaning that our true angle we are supposed to use is what? 270 degrees. So now you just write your final answer to be my magnitude. What was our magnitude? It was the root of 7, then cos 270 degrees plus I sine 270 degrees, or z, the magnitude less than the argument 270 degrees, like that. Then you are done. Thank you guys for watching. We have come to the end of our tutorial. See you in the next video. Shalom, shalom.